Good afternoon, everyone. This webinar, Climate Change and Wetland Restoration, is the first in a series of 3 Together North Jersey Resilient Task Force webinars. It was developed by Rutgers University for the Together North Jersey Resilient Task Force. For more information on this webinar series and to register for the 2 future webinars, please visit the Together North Jersey website. Before we begin, we have a few webinar instructions. First, please be sure to mute your phone as this webinar is being recorded and will be available at the Together North Jersey website, togethernorthjersey.com, at a later date. Next, please direct any questions to the bottom right chat box on your screen. We have reserved the last 10 minutes of this 1-hour webinar to answering any questions. Should we run out of time, please direct any remaining webinar questions to either myself, Stacy, or my colleague, Elliot, at the email addresses seen on the screen. The Resiliency webinar series, consisting of 3 webinars, of which today's webinar is the first, is a product of the Together North Jersey Resilient Task Force. We would like to thank the following Resilient Task Force members for their guidance and assistance: Rob Freudenberg, Tim Van Epp, Kelly Flicka, Linda Weber, and Melissa Harklerode. The North Jersey Transportation Planning Authority, referred to as NJTPA, is the federally authorized Metropolitan Planning Organization, or MPO, for the 13 counties in northern New Jersey. The federal government requires each urbanized region of the country to establish an MPO to provide local guidance over the use of federal transportation funds and ensure it is spent cost-effectively to improve mobility, support economic progress, and safeguard the environment. The NJTPA oversees more than $2 billion in transportation improvements each year. The NJTPA Board of Trustees includes representatives from each of the 13 counties, as well as from Newark and Jersey City. The board also includes a governor's representative, the commissioner of the New Jersey Department of Transportation, the executive director of New Jersey Transit, the chairman of the Port Authority of New York and New Jersey, and a citizen's representative. The Together North Jersey Resilient Vision is as follows. A resilient North Jersey is ready for adverse events, extreme weather, climate change, economic downturns, or other major setbacks, and can quickly bounce back from them. It protects wetlands and other crucial ecosystems and has strong, well-maintained infrastructure, transportation, utilities, water, sewer, etc. A resilient North Jersey takes steps to be prepared and reduce negative impacts on our communities. My name is Stacy Krause, and I will be the main webinar speaker for today. I am a research associate at the Edward J. Blaustein School of Planning and Public Policy at Rutgers, the State University of New Jersey. A little later in the webinar, I will turn the controls over to Leah Yasenchak, a principal at BRS Incorporated and former local recovery manager at New Jersey Future, to present a few slides on a resiliency project that she worked on in Little Lake Harbor in Ocean County, New Jersey. The following topic items will be covered in today's webinar: climate change impact projections, impacts on wetlands, using wetlands to combat climate change, project examples, funding opportunities and incentives, and lastly, a slide of listed resources and links noted throughout the presentation. The first section of this webinar will lay out current projections for 2 climate impacts: sea level rise and storm surge. The first climate change impact we'll address is sea level rise. A Rutgers-led Science and Technical Advisory Panel, referred to as STAP, was convened on behalf of the New Jersey Climate Adaptation Alliance to develop climate projections and probabilities for the state. The STAP has estimated a low sea level rise projection of 2.4 feet and a more likely to happen projection of 3.4 feet for the year 2100. Using these latest projections, New Jersey's regulatory agencies and local governments should generally plan for at least 2 feet of sea level rise for the year 2100. For reference, using the NJ Flood Mapper tool, the Meadowlands region, which is located in northeast New Jersey only a few miles from New York City and is made up of portions of 13 municipalities, is mapped above, showing water levels at current day high tide and sea level rise of 2 feet, or the lowest level estimate, with the progressively darker blue shading reflecting greater water depths. The second climate change impact that will be referenced in this webinar is storm surge. The National Oceanic Atmospheric Administration, or NOAA, defines storm surge as the abnormal rise in seawater level during a storm, measured as the height of the water above the normal predicted tide. The surge is caused primarily by a storm's winds pushing water onshore. NOAA also states that warming waters are likely to fuel stronger hurricanes, leading to greater levels of storm surge into the future. The map seen here illustrates levels of storm surge modeled for categories 1 through 4 storms in New Jersey, which are defined by the National Weather Service. The wind speeds associated with the different categories of storm range from speeds of 74 to 95 miles per hour for a Category 1 storm, to winds greater than 155 miles per hour associated with a Category 5 storm. Superstorm Sandy's highest winds were measured at 90 miles per hour at a station just across the border with Staten Island. Based on research done by NOAA's Hurricane Research Division, the state has a 6% to 30% chance of a tropical storm or a Category 1 or 2 hurricane affecting the area each year. This analysis also indicated that the state has a less than 1% chance per year of experiencing a major hurricane, which is a Category 3, 4, or 5 hurricane. This slide displays the Meadowlands area as an example of storm surge mapped by the NJ Flood Mapper tool. For reference, the first map to the left shows the extent of flooding caused by Superstorm Sandy. The second map illustrates storm surge projected for a typical Category 1 storm. As you can see, generally, there is projected to be some areas of flooding up to 3 feet above ground level. With a Category 2 storm, the model predicts some area with flooding of 3 to 6 feet above ground level, and with a Category 3 storm, some areas are projected to experience inundation greater than 9 feet of water. The next section of the webinar will discuss the impacts that climate change may have on wetlands, including impacts on wetland migration, wetland sediment, and wetland conversion. As sea level rises, wetlands migrate inland. In some areas, there may be barriers to this migration due to development on adjacent land or the presence of engineered structures, such as bulkheads, built too close to the wetlands without consideration given to the natural migration process. Ensuring land adjacent to wetlands is maintained in a state that would allow for this natural migration will, in many areas, be a local land use policy and property rights issue, where local development intensity will serve as the critical deciding factor for facilitating this landward wetland migration. Ensuring lands are available into the future can be accomplished by preventing development through setbacks and buffers, as well as open space acquisition, or by modifying the kind of development, particularly in terms of permanence, that can occur in and around these areas, through building code regulation and enforcement. The New Jersey Department of Environmental Protection regulates wetland areas and buffers. Before a property is purchased for development, the wetland limits of the area must be assessed in determining the development potential for the site. Extensive wetlands and/or buffers, or the presence of a threatened and endangered species, may limit or prohibit development of a property. Activities such as construction and renovations in a wetland or buffer area will require permits from the NJDEP. Failure to obtain the required permits may result in fines or penalties. In some areas, wetlands may keep up with the rate of sea level rise due to the buildup of sediment. Wetlands and their channels thrive on a steady input of mineral sediment that builds up slowly over time to counter sea level rise. Sediment is necessary in the development of aquatic ecosystems through nutrient replenishment and the creation of habitat and spawning areas. According to the U.S. Geological Survey, or USGS, most river and wetland sediment loss is due to dams and canals that restrict flow through complete detention of restricted channels, causing a downstream channel to become sediment-starved, severely limiting habitat and spawning areas. Too little sediment also results in receding riparian buffers, shoreline erosion, and wetland loss. A 2017 article published by the Yale School of Forestry and Environmental Studies, titled "Why the World's Rivers Are Losing Sediment and Why It Matters," describes a 5-year project taking place in California that is restoring the wetlands near Seal Beach Harbor with an experimental technique called thin layer sediment placing. During the first year, contractors sprayed sediment with a fire hose across 8.5 acres of marsh at risk of inundation. Over the next 4 years, researchers will see how well the wetland vegetation comes back as a result of the sediment. Freshwater wetlands that are close to saltwater wetlands are likely to experience increased flooding and/or saltwater intrusion from sea level rise. Saltwater intrusion also occurs in coastal wetlands where sea level rise and storm surge can cause freshwater wetlands to be inundated by ocean water. As salinity levels rise, the wetland's biology changes and its ability to support plant life and animal life is greatly impacted, including habitat for bald eagles, ospreys and egrets, and migratory waterfowl. Over time, plants that are adapted to live in freshwater conditions may no longer be able to survive when the water becomes saltier. Salt marsh plants may begin to move in to take their places, allowing for the opportunity for invasive species, like the common reed, also known as Phragmites, to rapidly take over as the freshwater plants begin to die off. If water levels rise too high and too quickly, freshwater wetlands could begin to go completely underwater rather than transition into salt marsh. This transition can be seen in areas in New Jersey by the presence of standing dead trees along edges of many forests that are next to salt marshes. This shows that some forest edges are starting to die off as they face increased flooding and/or saltwater intrusion. The next section of the webinar will discuss how wetlands can be used to combat climate change. This will include wave attenuation and carbon sequestration through the creation, restoration, and mitigation of wetland areas. One natural function of wetlands in combating climate change impacts is the wave attenuation they provide. Wave attenuation is measured by the decrease in wave height per unit of distance across a wetland area. With this, wetlands act as a buffer between the water and adjacent developed land, particularly in low-lying coastal communities. However, as storms occur over time, this natural function can be diminished as these buffers become eroded. Therefore, areas vulnerable to climate change impacts should be monitored, and if restoration projects take place, the project should plan for site monitoring and, when needed, future maintenance work, including manpower and financing. Another way wetlands act to combat climate change impacts is by sequestering carbon. According to the U.S. Environmental Protection Agency, emission of greenhouse gases from human activity is the #1 climate change indicator. The most emitted greenhouse gas is carbon dioxide, and methane being number 2. Wetland vegetation aids in mitigating climate change impacts by a process of dying plants being buried in the soil and covered by tidal water. These plants break down very slowly, resulting in significant carbon storage. Peatlands, for example, cover 3% of the global land area, but contain approximately 30% of all carbon on land, equivalent to 75% of all atmospheric carbon and twice the carbon stock in the global forest biomass. However, there is also science detailing that the expansions of wetlands, due to hotter, wetter weather caused by climate change, may actually be contributing to the emission of methane into the atmosphere. If anyone is interested in reading further into this topic, an article published by the Yale School of Forestry and Environmental Studies titled "What is Causing the Recent Rise in Methane Emissions" can be found on the resources slide at the end of this presentation. So what can we do? In a response to climate change impacts, there are a few things we can do to support wetlands in their role in mitigating these impacts. Specific projects range from wetland creation for stormwater management to restoration projects where wetlands have been battered by past storms. The legal definitions for wetland creation, enhancement, and restoration can be found in the New Jersey Freshwater Wetlands Protection Act rules. According to the U.S. Environmental Protection Agency, the state of New Jersey has active programs in place for ecological restoration and for protection of wetlands through land acquisition and watershed planning. Restoration is accomplished by both the New Jersey Department of Environmental Protection and in partnership with local governments, the federal government, and nonprofit and watershed organizations. One way to keep wetlands functioning and able to act as climate change mitigators is to restore wetlands that have been degraded due to lack of monitoring and maintenance, and also due to development or pollution. Ecological restoration is defined as the process of assisting the recovery and management of ecological integrity. Ecosystems are biological communities of interacting organisms and their physical environment. And ecological integrity includes a critical range of variability in biodiversity, processes, and structures. This would include the reintroduction of natural native plants that were once present at the site. According to the U.S. Geological Survey, wetland restoration projects can help maintain the benefits of wetlands, such as climate mitigation, and their surrounding ecosystems, and at the same time accommodate the human need for development. Aside from restoring previously existing wetlands, wetland creation is the act of constructing a wetland where one did not previously exist. This is done via a depression created in an upland area. The water that sits at the site will establish the hydrology that can then support wetland plant and animal species. Wetlands can be created for specific purposes, such as water quality treatment and for the storage of floodwater. The example on this slide is an example of a wastewater wetland that was constructed on Duke Farms in Hillsborough, New Jersey. The wetland serves as a filtration system for the wastewater from the building. The water is filtered through native plants and then is discharged back into the groundwater system. The wastewater wetland, along with other environmental activities and best practices at the site, garnered Duke Farms a 2015 New Jersey Department of Environmental Protection Environmental Stewardship Award. Duke Farms is the first organization in New Jersey to achieve a perfect score and be recognized in all 21 categories of stewardship, ranging from reducing greenhouse gas emissions to water and energy reduction. For wetland creation and restoration projects, New Jersey has developed a system of wetland mitigation banks. There are currently 21 wetland banks approved to sell mitigation credits throughout New Jersey's watersheds. The banks are critical in the development process, as Section 44 of the Clean Water Act states that although wetlands can be destroyed to accommodate development, compensation must be made by creating or restoring wetlands in another area. Wetland mitigation then offsets or compensates for expected adverse impacts to similar nearby ecosystems. Ideally, this transaction should result in a no net loss of wetlands. Once the mitigation project is complete, the mitigation banker is then responsible for the upkeep and maintenance of the wetland. When embarking on wetland creation and restoration projects, it is crucial to use and promote the health of non-invasive species. Due to the disturbance they can cause at a site, restoration projects by nature can cause sites to become vulnerable and inviting to invasive species. In New Jersey, Phragmites, or the common reed, are a very common type of invasive species. Their roots excrete a toxic compound, which then chokes out other plant life. This can result in the altering of not only the landscape, but also the ecosystem by impacting the habitat of the various other wetland plant species. There are resources available to learn more about native species and nurseries where they are available for purchase, such as the New Jersey Agricultural Experiment Station at Rutgers University, the Native Plant Society of New Jersey, and Jersey Friendly Yards. Bioengineering is important in wetland projects because it uses plant and inorganic materials to produce living, functioning wetland systems. These techniques offer erosion prevention, species habitat, stormwater runoff nutrient control, and flood mitigation. An example of such a project is the restoration of an area of Gandy's Beach in Cumberland County, New Jersey, using a technique called a living shoreline. A living shoreline is structural and organic materials, including sand, plants, fill, oyster reefs, submerged aquatic vegetation, stones and core fiber logs used to restore and protect eroded shoreline and marsh areas. For this particular project in Gandy's Beach, coconut fibers were interwoven and bound with biodegradable netting to help establish native vegetation at the site that had shrunk by nearly 500 feet since 1930. The project was done to reshape the existing coastline and improve habitat for coastal birds, and also provide flood protection by acting as a natural buffer from storm effects to the homes, businesses, and roads located in the adjacent area of Down Township. The next section of the webinar will offer some more examples of wetland projects, from a large-scale restoration of a landfill site to a small-scale lakeside park restoration. In Lincoln Park in Hudson County, New Jersey, 42 acres of tidal wetlands was restored on what had become an illegal dumping ground, where over 250,000 cubic yards of illegally dumped materials were ultimately excavated. This project was done by Lois Berger for the New Jersey Department of Environmental Protection. Over $10 million in funding for this project came from the National Oceanic and Atmospheric Administration through the American Recovery and Reinvestment Act, commonly referred to as ARRA. Along with the ecological benefits of wetland restoration, such as bird and fish habitat, the project also created recreational space needed in Hudson County, and to satisfy U.S. Army Corps of Engineer project requirements, the dredge material from the Hudson River was reused as the planting base of the marsh. I'll also note that this project garnered a letter of commendation from the Secretary of Commerce in the Obama administration, and Rebecca Blank won a Coastal American Partnership Award, which recognizes outstanding projects that make a significant contribution toward the restoration and protection of the United States coastal environment. This is the only environmental award of its kind presented by President Obama's administration. The Richard P. Kane Natural Area, located in Carlstadt and South Hackensack in Bergen County, New Jersey, is over 580 acres in its entirety, with 237 acres of wetlands, mostly tidal and some freshwater. These wetlands, which had become dominated by Phragmites, were restored to reestablish plant and animal life, improve water quality, and provide flood protection to adjacent landowners as part of a mitigation bank credit project to offset development in the Hackensack Meadowlands region, specifically surrounding Continental Airlines Arena and Teterboro Airport. This site is owned by the Meadowlands Conservation Trust, and project and funding partners included the Army Corps of Engineers and Enviro Finance Group. Although public access is not available within the main part of the Kane Tract at this time, according to the Meadowlands Conservation Trust, access has been provided to the waterfront and a panoramic view of the lower 42 acres of the property at River Barge Park's Robert Siberio Environment Education Pavilion. The Trust worked with the Meadowlands Commission to make the waterfront trail and pavilion, along with the adjacent marina facilities, a central recreational and educational station where the public can engage in a first-hand experience learning about Meadowlands ecology. Our next example is River Edge Restoration at Newark's Branch Brook Park Lake. This Essex County park is a total of 360 acres located at Park Avenue and Lake Street in the city of Newark, and is home to events such as Jazz in the Park, historic guided tours, and an annual Cherry Blossom Festival, and includes features and amenities such as ball fields, a senior citizen center, and a fitness course. This project restored the lake edge by creating stormwater runoff controls and a riparian buffer, or a vegetated buffer, to protect the lake from adjacent land uses. Students from a nearby high school helped with collecting data, removing invasive species, and planting new vegetation. The goal of this project was to improve water quality in Branch Brook Lake Park, which is part of a tributary system that connects to Passaic River. The project was a partnership between the U.S. Environmental Protection Agency, Newark's Community Development Block Grant Program, and the New Jersey Corporate Wetlands Restoration Partnership. The Harrison Avenue landfill in the city of Camden in Camden County, New Jersey, capped and closed a 62-acre landfill and created the Kramer Hill Waterfront Park. The project created and restored 17.5 acres of tidal and non-tidal wetlands and 3.5 acres of open water, as well as tidal channels and habitat conservation areas. The co-benefits of the landfill closure include the creation of public recreational space, as well as wetlands and diverse ecological habitat. Also, 3,700 feet of eroding shoreline was stabilized, and there was beneficial reuse of the Cooper River dredge material to cap the site. Project partners included the New Jersey Department of Environmental Protection's Office of Natural Resource Restoration and the Division of Coastal Engineering, CDM Smith Sadat, Camden Redevelopment Agency, Cooper's Ferry Partnership, the Kroc Foundation, Kramer Hill Community Development Corporation, the U.S. Environmental Protection Agency, and other nonprofits. Funding for this project included $59 million from the estate of Joan Kroc, $10 million from private donors, and $26 million that the New Jersey Department of Environmental Protection had previously spent in Hazardous Discharge Site Remediation Fund grant money to remediate the site in 2009. I am now going to turn the webinar over to Leah Yasenchak to present a few slides on a resiliency project in Little Lake Harbor Township in Ocean County, New Jersey.
Thank you, Stacy. As Stacy said, my name is Leah Yasenchak, and I was the local recovery manager for Sandy impacted communities for New Jersey Future. And New Jersey Future is a statewide nonprofit advocacy group that focuses on revitalizing cities, preserving open space, keeping housing affordable, and encouraging transportation options. After Hurricane Sandy hit New Jersey in 2012, they launched a recovery manager program to assist hard-hit communities. Local recovery managers operated in the coastal communities of Seabright and Highlands in Upper Monmouth County, Commercial and Morris River in the Delaware Bay Shore in Cumberland County, and Little Lake Harbor Township in the borough of Tuckerton in southern Monmouth County. I was a local recovery manager for Little Egg and Tuckerton from fall of 2013 through early 2016. The objectives of the local recovery manager program were to provide local capacity for recovery, planning, and long-term resilience, to identify vulnerability to likely hazards, including flooding due to storm surge and sea level rise, to advance the dialogue at the leadership level and at the community level around long-term planning for resiliency, and to identify and develop projects that would increase the resiliency of the communities to future storms. The primary resiliency project that was identified in these communities was the need to protect the marshes and dredge the lagoons. The dredging of the lagoons is important to the community to maintain economic sustainability, as the ability to access the bay via the lagoons is a big driver of property values. The lagoons fill with silt that erodes off the marshes and become too shallow to navigate. The marshes, on the other hand, experience a net loss of material, and while the marsh in this area is generally considered to be extremely healthy, there are low portions which experience frequent inundation. We designed a project to use the materials dredged from the lagoons to backfill behind a living shoreline in areas that were experiencing severe erosion that threatened community infrastructure, to replenish a beach in Tuckerton that had eroded, and to place a thin layer of material on low-lying areas of the marsh in an effort to help the marsh keep up with sea level rise. In 2014, we applied for and were fortunate to receive $2.13 million from the National Fish and Wildlife Foundation as part of their Sandy recovery funding round to move this project forward. The New Jersey Corporate Wetlands Partnership then committed approximately $50,000 to assist with the monitoring of the project after completion, and we received an additional $400,000 from the NJDEP Section 319 Water Quality Grant toward the living shoreline portion of the project. This is a particularly complex restoration project and requires the cooperation of lots of partners. In addition to the funders NJDEP, the New Jersey Corporate Wetlands Partnership, and the National Fish and Wildlife Foundation, they're the two municipalities where the work was set to occur, the Borough of Tuckerton and the Township of Little Egg. Working across municipal boundaries can be challenging, particularly as only one can be the actual grantee, in this case, Little Egg. In addition, particularly given the importance that the selected dredging locations had to individual residents, the project was very politically charged. We also needed to work with the landowners. In this case, the New Jersey Natural Lands Trust's Mystic Island Preserve is where the Little Egg Harbor living shoreline is slated to be constructed, and the New Jersey Division of Fish and Wildlife owns the land where we wanted to place the dredge material in a thin layer across the low-lying areas. Both these entities would have to sign off on the plans. Of course, we also have the permitting agencies, particularly the New Jersey Department of Environmental Protection Division of Land Use, but also the Army Corps of Engineers. We also have a team of professionals involved, including the Barnegat Bay Partnership, who will be conducting the monitoring, T&M Associates, who are the design engineers, and New Jersey Future and BRS, who are serving as project and grant managers. In an attempt not to scare anyone off, I want to emphasize that there are many wonderful restoration projects that are much more straightforward. This one involved several different units of government and an emerging technology and was definitely more complicated than a typical project. The maps shown here demonstrate the areas where the marsh currently experiences tidal inundation, shown in red on the top map, and the extent to which sea level rise is expected to exacerbate this issue with 1.4 feet of sea level rise. It is not fully understood how the marshes will respond to this, but the concern is that the rate of accretion on the marsh, or the rate at which the marsh is able to grow from the accumulation of additional material, will be overtaken by the rise of the sea level, and that the marsh will eventually convert to open water. Attempts to address this are complex and emerging, with several hot-button issues. I've already mentioned some of what I'm calling programmatic challenges, the two different state agencies that had to sign off on the project, the two separate municipal governments, one of which had a change in administration during the course of the project, and the widespread political pressures and intense interest surrounding the dredging portion of the project. Of course, we also faced permitting challenges. While the Living Shoreline Project component is well understood, the thin layer portion of the project is an emerging technology. While it has been used in other parts of the country, it doesn't have a long track record of monitoring as of yet. In addition, the only such projects to date in New Jersey were occurring as the permit applications for this project were being developed. As a result, no clear guidance for the data that was required, the parameters by which recipient areas should be selected, or the monitoring protocols had been determined. DEP was struggling to define these while we were trying to put together the permit application, and as a result, the goalposts kept moving. DEP's concern was to ensure that no harm occurred to the marsh as a result of the application of dredge materials. This required careful understanding of the recipient areas, the depth the material could or should be applied, the replanting, and the monitoring. Our initial sampling mobilization involved sampling the areas where the material would be coming from, the lagoons. However, we were then required to go back out and sample the areas where we were looking to place the material. After visiting the areas proposed for placement, DEP indicated that these would not be acceptable, and additional sampling in additional areas had to be conducted. In addition to these delays and expenses, DEP was considering what type of financial assurances they would require to ensure that if any harm did come to pass on the marsh, that it would be corrected. One of the landowners, the Division of Fish and Wildlife, eventually proposed a memorandum of agreement that would give them the authority to cancel the project at any point, require an open-ended insurance on the project, among other requirements. By this time, the town had reached an extreme level of frustration. The primary funding source project period was about to expire, despite 2 extensions, and significant funds had been expended over a 2-year period with no construction or permits in sight. It became clear that we needed to be flexible and open to changing directions. The towns decided to pivot in order to ensure a successful and impactful project and show some positive results from the effort. The permit application was withdrawn, and new permits for an expanded living shoreline in Little Egg Harbor and a living shoreline and beach replenishment project for South Green Street in Tuckerton were submitted. It is anticipated that these more traditional applications will be approved quickly, and the bulk of the construction will be completed by the end of the calendar year. The National Fish and Wildlife Foundation funding expires December 31st, so time is critical. An important takeaway of this project is that some marsh restoration projects can be complex, particularly if emerging technologies are being considered. When attempting to tackle some of these more complex projects, additional time and money must be budgeted to account for the inherent uncertainties, and it is important to recognize when it no longer makes sense to pursue a particular course of action and when it is in the best interest of the communities to pursue a different approach. And now I'd like to turn it back over to you, Stacy.
Thank you, Leah. That concludes the Wetland Project Examples section, and we'll now move on to the final section of the webinar, which will focus on funding programs and incentive opportunities related to wetlands projects. The Watershed Institute's Grant Finder database contains information on more than 100 grant opportunities that may be of interest to watershed and other environmental groups throughout New Jersey and beyond. Within the database, users can search for specific projects that had previously received funding dating back to 2010. Also, keywords can be used to locate grants that best fit the activity that one may be looking to fund, such as monitoring and education. The Watershed Institute's targeted actions include water quality science and education, stormwater policy, green infrastructure, and climate change resiliency. The database also lists detailed information on eligible regions, grant timeframes, and information on eligible applicants. Currently, grants given directly from the Watershed Institute and funded by the Geraldine R. Dodge Foundation include project grants of $1,000 to $10,000, and letters of inquiry for these grants are due by August 3rd of this summer, and expertise grant applications of up to $500 are accepted on a rolling basis. The New Jersey Corporate Wetlands Restoration Partnership is a partnership of private corporations, federal and state government, conservation organizations, and academia to protect, enhance, and restore important aquatic habitats and water quality in New Jersey. There have been 32 projects completed in New Jersey that have received some level of funding from the partnership. There are 9 approved and current projects, and 1 project currently under review. Corporate members of the partnership include PSE&G, Exxon, JCP&L, Pfizer, and more. Non-governmental organizations, or NGO members, include the New Jersey Audubon, the New Jersey Conservation Wildlife Foundation, and New Jersey universities. Business association members include the New Jersey Chamber of Commerce and the New Jersey Utilities Association. Government agency membership includes the New Jersey Department of Environmental Protection and the New Jersey Board of Public Utilities, along with the U.S. EPA, among others. New Jersey Corporate Wetlands Restoration's partnership grant priority is given to projects that include an educational component, have matching funds available, and have their permits in place. Past funding has included costs related to dam removals, signage, surveys and monitoring, and the purchase of project materials such as fencing and vegetation. More information on past funding can be found in the Grants Metrics Report located on the partnership's website. An example of a project where partial funding was given by the partnership is the restoration of nearly 4,000 feet of the Squonkam Brook in Monmouth County, where project partners included Howell Township, a nonprofit, and the U.S. Fish and Wildlife Service. For this project, the partnership awarded $25,000 for restoration efforts. The 5-Star and Urban Waters Restoration Grant Program of the National Fish and Wildlife Foundation funds projects addressing water quality issues in priority watersheds, such as erosion, stormwater pollution, and degraded shorelines due to development. Funding priorities for this program include on-the-ground wetland, riparian, in-stream, and/or coastal habitat restoration, meaningful education and training activities, either through community outreach, partnership and or integration with K through 12 environmental curriculum, measurable ecological, educational, and community benefits, and projects that engage a diverse group of community partners to achieve ecological and educational outcomes. The Schuylkill River project restored a half-mile wetland habitat on the Schuylkill River, which is Philadelphia's only natural tidal wetland. The project included paid water quality monitoring positions for underserved youth and partnership with two nonprofits, Bartram's Gardens and Philadelphia Waterborne, as well as Drexel University. For municipalities participating in the CRS, or Community Rating System, which is a voluntary incentive program that gives points to communities who exceed the floodplain management minimums of the National Flood Insurance Program, or NFIP, points are available for activities such as habitat restoration for both state and federal threatened and endangered species, the adoption of floodplain and habitat conservation plans, providing and publicizing outreach on protected areas, preserving open space, and attaching deed restrictions to open space parcels. If a community participates in the NFIP program and local officials and professionals implement these actions, homeowners within the community who have NFIP policies receive a certain discount on their flood insurance premiums. More details on wetland-related activities that may garner CRS points can be found in FEMA's CRS manual. Should anyone want to take a deeper dive into any of the content of this webinar, the next slide is a list of resources referenced, and as a reminder, this webinar will be available at the Together North Jersey website at a future date. In terms of trainings related to wetland restoration, the Jacques Cousteau National Estuarine Research Reserve, commonly referred to as JC-NER, located in Tuckerton Township in Ocean County, New Jersey, offers professional development and training workshops on various topics, including wetlands topics. The best way to get information on these trainings is to join their email listserv. It should be noted that the JC-NER trainings are generally geared towards elected officials and professionals from coastal communities. That concludes today's webinar content. We will now start a 10-minute Q&A, and as a reminder, if we run out of time, or if you are unable to stay on the webinar beyond this point, you can email questions to Stacy or Elliot at the email addresses listed on the screen. With that, I will begin reading off questions from the chat section on the bottom of the screen.